Trying to visualize a vector field in 3 dimensions can be fairly tricky, so it's usually a good idea to have some sort of a graphing utility help us with that. I'm using CalcPlot3D here to visualize our vector field, and I've set it up so that we can see different levels, different heights, if you will, where the vector field exists in 3 space. And I've also set it up over here with the x-coordinate, which is m, being -1. The y-coordinate for the vector is going to be 1. That's called n here. And p equals 0 is the z-coordinate for the vector at any particular point in space. So what we see with z being equal to 0 is that at any particular layer that we've plotted here, there's no vertical component to the vector. They all lie flat because there's no vertical component. If I add a vertical component, we can see how that changes the overall vector field in terms of how it looks. So this one, again, has no particular vertical component to it. We can look at it from the top down, which can be kind of useful for analysis purposes. And now we're just looking at the xy components top down on our vector field. And you can see here these vectors look like they have a slope of -1 and can be seen over here because m is -1, the x component, and the y component to each particular vector is also 1. So taking those into consideration would give us a slope of -1, even though the vectors themselves are effectively pointing in the other direction. We still see them as having a slope of -1. So that's just one type of vector field we can look at. I can also look at something where maybe the x and y components are going to be 0 and the vertical component is fixed at a number. In this case, again, we can see that we just get a bunch of vertical vectors at various locations, and there's no x and y coordinate to those. So looking down on it from the top down, we basically see nothing. There should be a bunch of points here on the graph because we're looking directly down onto the vectors themselves, but this is what we get. If we maybe take y equal to 2 and z equal to 0, and we replot this, now what you can see is that all the vectors point in one direction along the y-axis because there's no change in those vectors in the x direction or the z direction. So that also should make sense. So we can vary this a little bit more. We can look at maybe what happens when x equals -y. Maybe we'll make y equal to x, and let's keep z equals 0 just for simplicity. So now in this case, if we look at our vector field, you can see at the various levels that we've plotted that it actually has sort of a circular shape to it. And from the top down, you can see that a lot more clearly. So if we're over here in quadrant 1, say, then we end up with x and y being positive in this quadrant. For the vector, that would mean that x is equal to -y, a negative number, and y would be x, a positive number. So its slope would be negative. And again, the fact that the arrow points here upwards is not relevant. We're just looking at slopes to help us understand how these particular vector fields are coming about. If we say go over into quadrant 2, here you have x being negative and y being positive. So if x is negative, then in the vector, the x coordinate would be in positive and y is positive. So there the slope should be positive. And you can see from our vector here that we do end up with something that looks like a positive slope that we would recognize. And of course, we could work our way around. This particular application will also show us flow lines if we click in various locations. So it's helpful for us to be able to visualize what our vector field is doing. And if we take this out, we can see where that ring lies in our total vector field in 3D. So let's maybe just play with one more just for something different and visual. Let's take -y squared plus x squared. We'll make n to be x squared, and let's take z to maybe be 1. So now you can see something just sort of wildly different in terms of a vector field. Probably not something we would be able to visualize on our own. So again, having that graphing utility is helpful. Top-down view here does look a little bit strange. We can play with these flow lines just a little bit just to see if we were looking at, say, airflow through this, or maybe how a particle might move through this vector field. You can kind of start to get a sense for how that curve, or vector field rather, behaves as we move through it. And again, just visualizing that in 3D. You can see the flow line there as well. So again, kind of challenging to visualize these things, but a good idea to have some kind of a utility to help us graph these vector fields.